Hi, my name is Paul Brannan. I'm from Mount Pleasant, South Carolina, just a few hours down the road. I work for a firm down there that does automated stock trading. And we have a trading system that's written in C++. Started writing it about 7 years ago. And we needed a system, a framework for being able to test our system. And I was the new guy, so they tasked me with it, and was just learning Ruby, and got started in writing some C++ extensions in order to test our system. The result of that was that we ended up with a system where we where we could build our tests very quickly. Rather than writing our tests in C++, we were able to write our tests in Ruby, and instead of having to recompile, wait for the test to compile, and then run it and find out that it fails and have to go through that whole process again, we're able to write our tests in Ruby, and on top of that, we're able to use Ruby to control our system in production as it's running live. So there's a lot of gotchas when you're writing extensions for C or C++. If you've never written an extension, I don't want to scare you away from writing extensions. It's not really that hard, but there are some things that you need to be aware of when you're doing it, so that you don't end up with these unexpected crashes and you have to spend hours running Valgrind trying to debug it and whatnot. So who here was playing Werewolf last night, or played Werewolf at RailsConf? So what's the most important thing when you're playing, or not maybe the most important thing? What do you do when you're playing Werewolf? What's some strategies?
Accumulate every data point you have, and you build a bunch of different scenarios to evaluate which is the most likely one.
Okay, that's kind of what I was going for. So accumulating a lot of data points. And how do you accumulate data points? Right, focusing and observing. So when you're writing an extension, you need to be observant and look at your code. Hopefully you're pair programming. Maybe you're not pair programming. If you're the pair, you're not the one driving. You, of course, need to be watching and paying attention to details and being really meticulous. Because, like I said, there's a lot. Just one little thing that's wrong, and your code's going to crash. There are two reasons you might want to write some extensions. Those of you who are in the Rails community, you might be wanting to, or even not in the Rails community, you might be wanting to make your code run faster. You might be using Ruby inline for that, or you might actually be writing straight extensions, or you might want to have access to some library that provides some feature that's not available to Ruby directly. Generally, a library would be written in C or C++. Or maybe Objective-C. I've also seen some extensions that interface with Perl and Python. I'm going to talk about the second one rather than optimizing for speed. The concepts that apply to wrapping a library kind of also apply to writing your code for speed as well. Because what are you doing when you're translating your Ruby into C code? You're actually writing a library and then wrapping that library. So let's look at a simple example. If you've never written an extension before, this is your 5-minute introduction. We include the Ruby header file, and we have a function that takes two parameters. A value is just an object reference. It converts those object references into C int types, integer types, adds them together, and converts the result back into a Ruby data type and returns it to Ruby, so Ruby can work with that data type. And then we have to initialize the library. Every C extension has to have one of these init underscore functions, and we call RB-define global function to give ourselves an add function. And MKMF works fine for me. You can also, I guess, use rake. For simple examples, MKMF is really quick. Create a make file. We build the extension with make. and then we can add 2 and 3. Pretty straightforward. Well, let's look at a real world. Let's look at a real world example. Something interesting. Let's build Hello World, because everybody builds Hello World. That's real world. No, let's build a just-in-time compiler. Serious. So of course we're going to use Ruby, and we're going to need a C compiler because we're building a C extension. And we're going to use libjit. Libjit is a library for building just-in-time compilers. There's a couple other options. LLVM is one, and GNU Lightning, I guess the Rubinius guys are using that. But the nice thing I like about libjit is you have these objects that abstract away your registry. So you don't care whether you're storing data in memory or in a register. You just store it in a value, and libjit takes care of optimizing it for you. We're going to build a 4-function calculator using postfix notation, and then just-in-time compile our 4-function, our postfix expression. But first, let's look at an example using libjit. This isn't a talk about libjit, so I'm going to gloss over this kind of quickly because we're more interested in looking at extensions. To create a function in libjit, you need to create a function signature specifying the types of the arguments and the number of the arguments and the return type. You need to create a build context and lock the build context. Specify the instructions in the function body, add or jumps or whatnot. Then we call a function to compile. Call a function in the libjit library to compile the function, then unlock the context. So here's an example of adding two numbers in C. We have this compile add function is going to create the signature, takes 2 ints and returns an int, and we call JIT value get param to get the first and second, or the 0th and first, depending on whether you start counting at 0 or 1. Parameters to the function, call JIT instruction add to add the 2 numbers, and then JIT instruction return to return the result back to the caller. And then we compile the function, destroy the context. And now our add function looks like this. We convert the numbers into integers just as before. Then we call JIT function apply to call the compiled function, and then destroy the build context, and then return the result, which was stored in the result variable by JIT function apply. And our initialize looks just the same as before. And we get 5 when we run it. That's not exactly a JIT compiler. It was compiled at runtime. We need a parser and a script to compile and run our code, which I'm not going to talk too much about. But we do need a wrapper for libjit. So we're going to build a library called littlejit, which is not going to have jumps or branch instructions or conditionals or too much, just enough to build a 4-function calculator. And it's just going to work with integers. Libjit is capable of working with other data types as well. So we need to be able to create functions, append instructions onto the function body, and compile the function to be able to call the function. We will also need to be able to store temporaries and values. These are placeholders. A JIT value T is a placeholder for the return value of an instruction, so that libjit can figure out whether to store that in memory or in a register. And we'll also need constants. If we're going to add 1 plus 1, we need to be able to represent the number 1. So let's look at creating a function. Here is, I've abstracted away I've abstracted away a lot of the libjit specifics into create function, and that's going to create a function object which contains both the context and the function together, and returns a pointer to that function. It's going to be a function that takes num_args arguments, num_args integer arguments, and returns an integer. And then we're going to return it back to Ruby with data abstract. If you've ever written an extension before, you've probably used the data abstract macro. It takes the class that you're wrapping, a mark function, a free function, and the pointer that you're wrapping. Does anybody see anything wrong with this code? There's no free function. Okay, that's a problem for sure. We'll get to that. I think I write that later. I hope I write that later. Oops. One thing I want to point out, notice that num_args_v and num_args they both represent the number of arguments, but one is a Ruby type and one is a C type. So I want to call both of them num_args, but I can't give both of them the same name. So I use the notation num_args_v if it's a Ruby object to differentiate it from the C object, and I use the num_args for the without the underscore v for the C object. The Ruby interpreter actually isn't consistent about this. If you go through the source code, there's a number of different notations that they use. Big Num uses v and pv. Y uses emitter and emitter pointer. The only one on this list that I don't like is object and data. What kind of data is that? The important thing to remember, though, is to be consistent. Whatever your personal preference is, if you'll save yourself a lot of trouble coming back and looking at your code later and trying to figure out what the variables are. I mean, I know this sounds like common sense, but if people were keeping it in mind, we wouldn't be in trouble with a lot of code out there that's not consistent. Also, something to keep in mind, we convert the number of arguments from the Ruby type to the data type with num to ulong. If I'd use num to int, though, with an unsigned long type, then I'm mismatching my data type with my conversion macro. And if you do that, it might seem to work now. Later on down the road, you hit an edge case and it's not going to work. Hopefully your tests will catch that, but they might not. So you want to keep an eye out for that to make sure that your data ranges and your data types match your conversions. And prefer to use the num versions of the macros, since those actually do validation. If you use the fix to int, it's not going to do validation. You can get yourself in trouble if you pass a string in. We also need to be able to compile our function. I did go ahead and implement the function free. I just didn't backport that to the earlier version of the code. So here's we compile our function. We lock the build context. We yield to the caller, so the caller will be able to specify what instructions are in the function body. And then we call JIT function compile to compile the function, and then unlock the build context. Does anybody see anything wrong with this code? Is this code exception safe? What do I mean when I say exception safe?
If the yield, in this case, if the yield fails or raises an exception, you have to hold the context.
Right. If the yield raises an exception, the context won't be unlocked, and you won't be able to call compile again because you'll deadlock when you try to lock the context again. So thing to keep in mind is exception safety is paramount, not just in C extensions, but also in any code that you write. You want to make sure that if any resource that you allocate, you also deallocate in the same, hopefully in the same place. And how do we do that in Ruby? You'd use ensure. In C++, you can use RB ensure, or you can use RB protect. The other thing that's wrong with this code, and you wouldn't know this unless you were familiar with libjit, was when I called JIT function compile, that returns a Boolean specifying whether compilation succeeded or failed. So if I go back, oops, oh, wrong button. I run this. Well, it turns out the compilation actually failed because there's no function body, but I didn't know that because I didn't check the return value. Again, something that should be common sense, but I've seen it missed before. So now we can use rbensure to ensure that the code, that the function gets cleaned up properly, and we check the return value of JIT function compile to raise an exception if there's an error. Same test, and this time it raises an exception because there's no function body. But libjit isn't very good at giving you reasons as to why it failed. It just tells you, no, I failed. So how would we unit test this code? I've spent a little bit. I wanted to come up with some examples for that, but it's actually kind of hard because libjit's not built with unit testing in mind. And that's the same. That's true with a lot of C libraries out there. They were written before unit testing was really popular, and so they don't support mock objects or whatnot. And if you build a layer between your code and the C code, so that you can test it so you can inject mock objects, you're not really testing what you want to test because you want to test to make sure that you're calling the C code correctly. So I say don't bother with it. Don't bother with unit testing. That doesn't mean don't test your code. You definitely want to write tests, but you don't need to test your extension as a unit. It's okay to go ahead and test your extension with the library. But another alternative, if you're so inclined, is you can rewrite the library so the library itself is unit testable. If you're wrapping a database library, for example, you could rewrite that database library so it lets you connect to a mock database. So you could actually do unit testing with your extension. Now we need to be able to append instructions onto the end of the function body. And of course, instructions return results, and those results get stored in values. So we're also going to look at the JIT value t, wrapping that at the same time. So that here's the getParam function. We call JIT value getParam just like we did with the add example, and that returns us a value, and we wrap it just like we wrapped a function. Again, what's the problem with this code? Similar problem as with the function that we saw before. There's no free function. So if the garbage collector decides to collect this object, the value is still going to be around. So I could add a free function for the value and try to free the value when I'm done. The problem with that is who owns the value? The function owns the value. So if I free the value, then things are going to break. So you want to consider when you're writing extensions, who owns the data that you're working with. If you don't own the data, you shouldn't be freeing it. In this case, Ruby shouldn't own the value, so it shouldn't free it. The function owns the value. And Ruby owns the function. So if the value gets destroyed, if the function gets destroyed and the value is still around, and you try to use that value, your code's probably going to crash. Why? Because the value belongs to the function. The value knows about the function. the solution to this, did y'all follow me on that one, or do I need to explain it again? Okay, I'm getting some nods. One solution, there's a couple different solutions to this. One solution would be to use some of the libjit specific internals, but I'm not going to do that because it wouldn't be a very generic example. I've got a hash that maps the pointer to the value to a function object reference. The result of that is that, now when I go to mark the value, it also marks the function. So as long as the value is around, the function stays around. So my code's not going to crash anymore if I happen if all the references to the function happen to go away. And of course, when I wrap the value, I need to insert the value into the function. Into the hash. Sorry, reading what's on the screen and not what's I'm actually supposed to say. We also need to be able to call our function, and that's I'll show you that real quickly. We iterate over the arguments that are passed in and insert them into a data structure, so we can pass them to JIT function apply. And we also need to have constants, so we can represent the numbers 1, 2, and 3, and so on. And those are wrapped similarly to the way we wrap values. And I'm not going to spend much time on this, but here's the 4-function calculator. It basically just uses a stack. It's regular postfix notation. When we see an operation, we add the appropriate instruction onto the end of the function body, so the compiler will be able to compile it, and it's inside a compile block, so that when it reaches the end of the block, it'll get compiled, and then we can call apply. So now I run calc.rb, 7, 8 plus 7 plus 8 is 15, divided by 3 is 5. So that's a just-in-time compiled 4-function calculator. Is this code safe? Is it secure? I know we have a few people in the audience who are concerned with security. If you have web applications out there, it's not secure. Well, it kind of is. Who's going to care if you're executing arbitrary add and multiply divides on your CPU? But if I were to add additional instructions, then there might be some security concern, because I might be executing arbitrary code, or I might be using tainted data. It wouldn't be as big a deal with this, but it might be a bigger deal with a web application if you're using tainted data and you're using Ruby security model. If using different security model, it might not be an issue. Wrong. So just always make sure that you call RB secure to make sure that you're in a low enough security level, and to make sure that you're not using tainted data, you can call RB check safe object or check safe string. So what have we talked about so far? We talked about consistency in naming. We've talked about consistency in making sure that our data types match up with our conversions. We've talked about checking return values from C functions. We've talked about exception safety. And we've talked a little bit about unit testing and making sure that you're keeping in mind who owns your objects, and a little bit about security. So let's look at another example. I told you I work for an automated stock trading firm. So let's look at a simple an application that just looks up stock information. We're going to have a lookup function that's going to return a boost shared pointer. So this is going to be a C++ example. Look at the header file first. We've got a symbol info structure that keeps track of the name of the symbol and the QSIP, which is a long string that uniquely identifies that security anywhere in the world, and previous day's closing price. And we've got a function called lookup symbol info that's going to return a shared pointer. Now, if you don't know what if you don't use Boost, you might not know what a shared pointer is. It's a reference count. It's a smart pointer for a reference counted object. So you create a shared pointer. The reference count is 1. You create another shared pointer from that shared pointer. The reference count gets incremented to 2. You delete those shared pointers. The reference count decrements, goes down to 0. When it reaches 0, the object gets destroyed. So who owns the object? The shared pointer owns the object. So if we were to actually wrap the object itself, then you're going to have the garbage collector and the shared pointer clashing with each other, and you're going to run into problems. So here's the lookup function. I just simple function checks to see if the stock is either Microsoft or Google. Wow, Google's closing price on Wednesday was really high. Not quite a Berkshire Hathaway, but and here's what we do to wrap that structure. We call data wrap struct again, and this time our free function is going to call delete. Since we allocated it with new, you need to free it with delete. And we actually wrap the shared pointer, like I said, not the underlying object. So that way, when Ruby destroys the shared pointer, the reference count gets destroyed. If anybody else still has a reference to the object, they're still okay. If the reference count drops to 0, then the object is destroyed. Of course, this requires that we dereference the pointer twice. We have to dereference it once to get the raw pointer, and then dereference it again with the arrow operator. So it's a little bit of overhead in typing to do that. I don't know if you noticed, but the lookup symbol info function can throw an exception if the symbol doesn't exist. So what happens if a C++ exception escapes into Ruby code? Does anybody know? Pardon? It's not pretty. I think what happens on G++ is std terminate, it's called, which is probably not what you want to happen. There's some real simple rules. Basically, at every barrier, anytime you go from C++ to C code, Ruby is written in C, remember, you want to convert your C++ exceptions into a Ruby exception, so it'll do a long jump. Of course, Ruby exceptions being implemented with long jump, that's not compatible with C++ code, because if you have an object on the stack, its destructor isn't going to get called. So on the other side, if you have C++ code calling into Ruby code, the Ruby code returns back into C++, you need to translate those Ruby exceptions back into C++ exceptions until it reaches the Ruby layer again, and then translate the exception back into a Ruby exception. So here, that's what we do here. Now when we construct the symbol info, we've got a try catch, and we call RB raise to raise a Ruby exception instead of a C++ exception. Now, is this code exception safe? It's actually not, because data wrap struct can raise an exception. It's not. You wouldn't think that it could, but it will. I know for sure it will raise an exception on an out of memory condition. I think there's another case where it will raise an exception, but I can't remember off the top of my head. Oh, I forgot to run the example earlier. So we look up Google and it returns 707 like we expect. I'll come back to that code not being exception safe in just a second. I want to take an aside to look at another issue. And in fixing this other issue, guess what? We're going to fix that exception safety issue. So let's look at a data. Let's throw this data into a database. We're going to use pstore. Pstore uses marshalling. I know it's not a great database, but it's really simple. So look, it looks like this. We open a transaction, and then we try to insert the data into the database with the attribute assignment operator. And when we run it, of course it fails because we don't have a Marshall dump defined. Okay. So let's define Marshall dump. I really like this idiom for Marshall dump. I throw all of my member data into an array as Ruby objects, and then dump the array. And then when I go to load the data back in, I load the array, and then pull the data objects back out of the array in the same order that I put them in. It just makes for a really simple protocol for storing my data into a string. So this should work, right? Now that I've got Marshall dump and Marshall load, right? Still doesn't work. Okay, that's a strange error message. I don't really know what's going on. Oh, I think I know what's going on. When we constructed the object, we constructed the object using new. Marshall wants to call allocate in order to allocate a new object. By default, that's going to allocate an R object instead of an R data, which is the wrong thing. So we need to instead of using the old Ruby 1.6 style, you might not remember that, we're going to use allocate and initialize, which was introduced in 1.8 or 1.7. And now, when we allocate the object, we just allocate it with a null pointer. And when we go to create the when we go to create the object itself, to actually initialize it, we just set the data pointer member. And now, guess what? There's no exception safety issue anymore because we're not calling data wrap struct with an std string on the stack. And this time, we're able to insert into our database and remove and marshal stuff back out of the database. So things you might want to keep in mind when you're writing your extensions. Functions that people tend to forget when they're writing their extensions is, of course, Marshall dump and Marshall load. We've already talked about. Dupe and clone might not work as expected if you don't implement them. And one that really bothers me is a lot of people forget to implement 2s and inspect. So I go to print the object out, and I get the default object 2s, and it just tells me what kind of object it is. It doesn't tell me what's in there, and it's really not very useful for debugging. So remember to implement those. Some other things that can go wrong when you write, well, not other things, some things that we've already talked about that can go wrong when you're writing an extension. Your data conversions, you can get those wrong, like we've already talked about, mismatching them. Exceptions are kind of difficult if you, as we've already talked about, getting those exactly right, making sure that you don't have a Ruby exception traveling over the destruction of an automatic object. Incorrect object initialization, like we just looked at. Inheritance is a tough problem. If you wrap a point, if you pass to data wrap struct a pointer to a derived type, and then go to call a function, pass that pointer to a function on the base that expects a pointer to the base type, what's going to happen? You're going to be pointing to data that's deeper into your object. You're going to be and you're not going to be pointing to the right place. It actually turns out to be a really hard problem. I'd love to explain how to solve that problem, but I don't have enough time in this talk. It turns out that the simplest solution is to convert the object to its previous base type every time, so that if you have derived, you convert derived to middle, and you convert middle back into base. And the framework for building that is kind of complex. Also, you might use the Ruby API incorrectly. It just uses integers everywhere. Value and ID and symbols they all use the same. They're all integers basically. So you're passing integers around. You might pass the wrong thing into the wrong function. There's a lot of things that you can do wrong when you're calling into the Ruby API. So there's some tools that you can use for making this job simpler. A lot of people use Swig, the Simple Wrapper Interface Generator. Swig is a really cool tool. A lot of people have done talks on Swig at previous Ruby conferences or other conferences, so I'm not going to talk too much about Swig today. I'd hoped to do a Swig example, but I wanted to talk to you about Rice. When I first started writing C++ extensions 7 years ago, I started writing a library for getting the exception safety correctly. Our trading system uses Corva, which is very exception heavy, and so getting the exceptions correct was of extreme importance to us. So we started developing this library. In RubyConf 2002, I talked about a library for getting exception safety correct in a C++ extension. And that library has grown over the years into something that's actually kind of unmaintainable. So a number of months ago, I rewrote it. I released I haven't actually released it, but it's on RubyForge in Subversion. It's called Rice, the Ruby interface for C++ extensions. And it looks a lot like Boost Python. If you've ever used Boost Python, it's actually a direct C++ style interface to the Python API. And these tools will help you, or other tools like Ruby Inline. I know there's tons of tools out there. Will help you in getting these things right, so you don't have to write the C code directly. So if you want to do an integer conversions to and from integers in Rice, the old style up at the top, using ulong to num, versus just call toRuby. C++ already knows what the type of the object is because we have function overloading in C++. So why have to specify the type of the object? So toRuby automatically converts it into an object. Instead of using a value, there's actually an abstraction for object you can call. You could do y_v.call and then tell it what method you want to call. Or converting back from Ruby, you do have to specify what type you're converting to. So I can use num to ulong, or I can use from Ruby and tell it it's an unslong long because it's a template function to convert using the Rice style. Arrays make use of the toRuby abstraction. So I can create an array, and I can push 42 into the array just like I would do in Ruby. And behind the scenes, what's happening is Rice is taking that 42, it's converting it into a Ruby object, and then it's pushing it into the array. So you don't actually have to do that conversion yourself. Same thing with the assignment operator and the bracket operator. The bracket operator returns a proxy object, so you can use the assignment operator on the proxy object and use the same style of accessing the array as you would use in Ruby. And you can use the bracket operator to print the object out. It should print out 10. Classes in Rice. Here's a simple example of a class. The animal is our base class, or our middle class. Organisms are base class. We have a virtual destructor. If you ever write C++ code and use inheritance, don't forget to use virtual destructors. Very important. And a virtual function speak, which we can override in the derived class. We've got a class dog, which inherits from animal and overrides that function. And we just call, in our init function, we're just going to call define class, and we tell it what type that represents, and the name of the class, so Ruby knows what to call the class at the Ruby level. And we have the speak method is actually a method on the base class. And then we define the derived class, dog inherits from animal, and we give it a constructor so that you can actually construct an instance of the derived class. By default, Ruby lets you just construct an object, but Rice will not let you construct an object unless you define a constructor. That's I think the right way to go about it, because then you don't accidentally construct a Ruby object that should have been constructed as a C++ object. I could go through tons more examples, but I'm not going to. I'll let you check it out for yourself. Some final thoughts. Be observant, be meticulous, pay attention to detail, because there are a lot of details to consider. Think about your exceptions. Think about your edge cases. I know that these should be obvious things because it's things that we have to think about when we're writing Ruby code. But somehow, when we're thinking about all of the other details, we tend to forget these things. Think about object ownership. Think about who owns the object. Don't destroy the object if you don't own it. And if you do own it, if you do own the object, make sure you do destroy it. Testing. Of course, make sure you test your code. And think about testing up front. And use a tool if you can to abstract away some of these details. Are there any questions? Yes.
Any suggestions for the inevitable memory leaks? Is there any brilliant techniques for catching those or avoiding those other than remember the three?
The question was, are there any suggestions for avoiding the inevitable memory leaks? The only suggestion I can give is I can give two suggestions. One, use reference counting. Of course, reference counting has its own set of problems if you have circular references. But the nice thing about reference counting, especially if you're using C++, the reference gets destroyed. The reference goes out of scope. The object will get destroyed when the reference counts to 0. The other possibility is up front you can register your object with the Ruby garbage collector before you use it, and let Ruby take care of it. When the object goes out of scope, it won't necessarily get destroyed, so it's not good for resource cleanup, but it is good for making sure that the object gets destroyed at some point down the road. Any other questions? Yes.
If both of those things are an option, what's the best way to look for memory leaks?
Can you repeat that one more time?
What would be the best way to go about looking for memory leaks in C extensions in an application that is launched by Ruby?
The question was, what's a good way to look for memory leaks that are caused by an extension? I have used Valgrind for that. If you're on the Linux platform, if you use Valgrind with Ruby, you need to use a suppressions file, because what will happen is the Ruby garbage collector pulls a lot of really dirty tricks, and you run Valgrind on Ruby without a suppressions file, and you're going to get a lot of false positives. So a suppressions file will suppress warnings that occur inside the garbage collector, and then you can, when Valgrind exits, you'll get a report of all the memory leaks. There are some tools that have been released recently, and I can't tell you the names of them, that are helpful for finding memory leaks. They'll tell you how many objects of a particular type are allocated, if you happen to allocate a Ruby type. And they've been posted to the mailing list. Like I said, I can't remember the names of those off the top of my head. Any other questions? Tom?
What's your favorite strategy for passing arguments within an iterator?
For passing arguments within an iterator.
You've got an RB iterate calling extension, and you've got an iterator function that gets called every time to the list. And there's like one place where you can pass an argument.
I'm still not sure exactly what you're asking.
Okay, I'll ask offline.
Okay. All right, anyone else? All right, well, thank you for your time. I hope you have a good conference.